All right, oh joy, let's write equations of tangent lines. You might want to just real quickly read over this information right here. Okay, so we have a function f. We're going to find the equation of the tangent line to this function at the point where x is -1. So find an equation. Just immediately think when you read those words point slope. So we're going to need slope and a point. So we have x, we need y, put a blank here, and we need slope. All right, so coming over here, let's find the derivative and plug in -1. So this derivative for this cubic evaluated at -1 will tell us the slope of the graph, of the regular graph here. -1 squared 1, 12 minus 5, that's 7. All right, to finish the point here, we need to get the y coordinate. Well, that's going to come from the original equation, so just plug in -1 everywhere you see x. And that's going to be -4 plus 5 plus 3. There's 8 minus 4, so that's just what, +4. Okay, and using point slope, y minus 4 equals 7 times quantity x plus 1. Okay, if the line tangent to the graph of the function f at the point 1, 7 passes through -2, -2, then the slope at 1 is equal to. So we've got a tangent line to the graph of the function at 1, 7. 1, 7 is the point of tangency, but that tangent line also passes through this point. Well, if these 2 points are on the tangent line, then the slope between these 2 points is going to be equal to the slope of the graph. So delta y over delta x, and we're done. So in this case, these 2 points belong to the same tangent line, so 7 minus -2, 7 plus 2, 1 minus -2, 1 plus 3. Sorry, 1 plus 2, which will be 3. So we're going to have 9 over top, 9 on top and 3 on bottom. There wasn't anything else we could do with these 2 points besides do delta y over delta x. All right, so we're going to find the equation of the line tangent to this graph at the point where the slope equals 1. You'll need to use your calculator for this problem. So find the equation of the line tangent to the graph at the point where the derivative is equal to 1. Okay, so again, I need x equals, y equals, and m equals. Now in this case, I'm told that the derivative is 1, so the slope of the graph is 1 here. So all that's left for me to do is find the x and y coordinate to use point slope to write the equation of the tangent line. Okay, so for me to find x and y, I'm going to have to find x first, and once I get x, I'll plug it in to the original and get y, but it looks like I want the slope of this graph to be 1. So let me find the derivative and set it equal to 1. So I think we can jump off from here and come down here. So 4x cubed plus 4x, plug in 1. Oh yeah, you need a calculator for this, because if you were to solve for 0, there's not any factoring or anything like that that we could do algebraically. So we're going to go to our calculator. y1, y2 is one option. Find the intersection. And you do y1, y2, or you could simply move the 1 over and type in 4x cubed plus 4x minus 1 into y1 and find out where it crosses through the x-axis. Either way. So at this point, we're just going to go to the calculator. All right, so as a result of finding the intersection, okay, where the derivative intersects 1, I got x equals 0.23673. So this is the x-coordinate at which the slope of this graph is equal to 1. Okay, make sure you're able to do the same thing here and find that intersection. Now to get the y-coordinate, I'm going to type this into y equals and evaluate it at this x value. As a result of that process, this is the output, the y value. Okay, and so to find the equation of the tangent line, just finish by using the formula, the point slope formula. So a visual for this would be to perhaps type that equation into your calculator if it's not already there and look at that graph. Just as a side, the visual, x to the fourth plus 2x squared, it looks like an upward opening parabola, something like this. It's a little more narrow, I think. Okay. But if you graph this equation and then you hit trace and you type in this x-coordinate, it's going to put you at a point that's about right here. And if you kind of studied that point, if you looked at it, the slope through that point, the slope of the graph through that point, okay, looks to me to be about 1. So that's what we were finding. The location of the point where the slope of the graph is equal to 1. Okay, so that concludes tangent line.